Hey everyone, in this video we're going to be wrapping up the GraphQL series with a few more best practices, and then I'll turn you loose to take over the world with your own GraphQL servers and queries and mutations and so on. And before we jump in, if you haven't already liked and subscribed to the channel, I would appreciate it, and the YouTube algorithm would appreciate it as well. And regardless, thank you for spending some time with me today. I hope you find the tutorial enlightening and helpful, and that you had as much fun watching as I have had in making it. So the first section we'll be talking about is called Thinking in Graphs. And for someone like me, and perhaps also you, who knows object-oriented programming, this way of thinking about the world is intuitive. It's intuitive because it largely mirrors the world we live in. There are objects in the world, and they interact with each other, and they have attributes, and so on. And so whether you're defining these relationships in a database table and series of tables, or in a server language like Ruby, or a server interface like GraphQL, the entities and their relationships flow through naturally all the way from the database to the server, to the GraphQL, up to the front end and so on. So GQL is of course flexible enough that whatever format or combination of backends you have, it'll support them as long as your schema defines what is out there, and where the data goes to and from and so on. A lot of care and attention needs to be given to the naming of your entities and their relationships. Often they will mirror database tables and their names. But if you're converting a legacy project whose backend systems don't reflect how the data are being used, then you should prioritize the ultimate data usage when designing graph entities. And because ultimately you're creating a tool, that will be used for those purposes, for those end user, perhaps front end goals. At the same time, GraphQL is an interface to a database, and so you still do have to kind of take both sides into consideration. So that's kind of the first one for this video. The next of the best practices to cover here pertains to authorization. And this means making sure that only people who are allowed to access certain entities actually can, and others cannot. This is similar to, although a layer of protection beyond authentication, which pertains to a user being logged in or not. Having authentication in place is kind of the most basic level of authorization, since as it's used, it ensures that only validated, legitimate users can access the data that's being protected in the first place. Authorization goes a step further, and there are rules that say, for example, that only you can view your emails, or only you and your friends can see your photos on Facebook, depending on how you've configured your privacy. So that's the authorization aspect. In my current work right now, we have a lot of internal tools, and they're all gated by different permission groups that give and deny access to different users. And that's basically, kind of another way of thinking about authorization and how that works. So it should be handled in the business logic layer, although it can be done in GraphQL as well. And, in my experience, it's often done in both. There's kind of a front end piece, and then there's a GraphQL piece, and then there's like a back end piece. And this makes sure that no one can circumvent one layer of authorization to essentially access the data because they got around the layer that has the protection on it. That's actually something that I ran into a while back, where the authorization was implemented in, I believe it was the client, but because it wasn't implemented also at the GraphQL layer, someone could make a GraphQL call and be able to access it, although there was also a third layer of authentication and authorization in the back end. But that just kind of goes to show you how one layer can be circumvented, and that's why for every kind of touch point, it's good to have both the authentication and authorization in place to maximize security, which of course you want to do. So the next concept for our best practices is pagination. And there's a lot of data out there. And if you send a request for records of an entity of some kind without specifying how many or limiting it in some way or another, you're going to end up getting a lot of records back. I think databases paginate kind of by default on their own. So you wouldn't accidentally query for 1 billion rows, but but pagination is important to take into consideration. And there are a couple sensible defaults that exist depending on which system you're using. And like I said, maybe that would exist at the database level, or maybe it would exist at some other level. Could be 100, could be 25 is a very standard amount of records to be returned. So GraphQL has syntax to specify how many records you want returned, and if you want to offset, you can sort of incrementally work your way through, all the records in a collection. So in the standard 25 per page example, your input would first say limit 25, offset 0, and it would return you the records, the first 25 records, right? Records 1 through 25. And then if you wanted to go to the next page of results, your inputs would be limit 25, offset 25. And this would go back to the database, skip records 1 through 25, and then it would return the subsequent 25, which means that what's coming back to you is, records 26 through 50, right? And you can go up incrementally from there, of course. So it's also possible to, instead of keeping track of current pagination based on the number place where a record resides in the collection, it's also possible to use a concept called a cursor to signify place. And this entails thinking of your collection more as a linked list than as an array. And the cursor would be what you consider as the pointers, signifying to the previous and next records, and in the way that a linked list does. So I haven't encountered this too much personally in real life development, but it's good to know that it's doable if you want to. So all right, so there's one more concept to go through before we call it a day, and that is caching. GraphQL has support for caching, which saves you time and bandwidth in serving data. And this doesn't happen on its own without intervention on your part, without intervention on your part and in tandem with help from the back end. But essentially what you'll want to do is have a universally unique identifier for a given entity record. And through it, data can be held in memory so that the server doesn't have to reach all the way back to the database to service requests for that particular record. As long as the client and the graph and GQL are passing in the unique identifier when making those queries. So the downside of caching is, of course, the data can become stale, and thus a user would be viewing data that is outdated when being requested. So it helps to set an expiry to try to avoid this, but that's kind of out of scope for what we're talking about here. So that being said, that's all for this video. I hope you found it and the rest of the series helpful and thought-provoking. And I had a lot of fun kind of going through the GraphQL docs myself to put these together, and definitely check those out for further reference. But anyways, that's all for this video and this series, and thank you so much. I'll see you all in the next one.